Sorry to say that I need to. My iPad doesn't work, so I need to please wait for a while. Yes.
Recording in progress.
All right. We will start the lesson now. Turn on the camera. Let me know you're here, and we will start the lesson right away. Now, today we will go over with the topic with you on the surface area, right? So how does the surface area of solid affects the rate of a reaction? Now, this concept, you may heard it before, right? But our focus for today is mainly two parts, which you find it quite difficult. One is how does it really affect the rate in terms of graphical representation? In Form 1, what you just know is that if I break the particle, size becomes smaller, which means that the surface area becomes larger. So usually the rate of reaction will become faster, or maybe rate of, for example, even though you dissolve a spring, try to dissolve salt in water, the smaller the particle size, the larger surface area, and then you would have the faster rate of dissolving, for example. So you may heard of this concept before, right? So how about today, our task is to take a further look on the graphical representation. How does it behave in graphs, as well as collision theory? Okay, how we understand in submicroscopic viewpoint. Okay, how does those particles collide in order better understand that phenomenon, that surface area increase, rate will increase. Do you understand? Do you understand the whole flow of today's today's lesson? So we will start it right away. All of you have come back, is it? Let's check. Nằm ngoài thì cái mẫu mặt hình cho ca dần all right, so all of you here, good. So now refer to the book now. Is on page 38. 38. Now this is one. So first of all, a very first important concept about the particle size and surface area. So as just said before, particle size is smaller, which means that the surface area of solid being higher. Okay, so the rate of reaction will become higher. Okay, so and if you want to talk about it as collision theory, right, the arrow will be expanded to so many arrows in collision theory. So we will take a look on that later today. So that is our concept, first of all. Now be aware of the terms. And it is easily set as a trap that if I say the surface area, most of you can get it correct, right? Surface area increase, rate of reaction increase. But that concept is not so layman, right? In layman terms, what you just said is particle size, right? How big or how small it is. So it's time to take a look on those size, about particle size, so as to let you know more about the difference in the surface area. Now, you may heard of so many different naming, right, of the description of a salt. For example, lumps, ribbon, granules, powder. Okay, do you know the difference between them? Do you know the difference between them? You know the difference? Now it's time to show it in graphical way. What is mean by that? Lump. What is that? What is mean by lump? You don't know? Zhang Ho Zheng, what is mean by lump?
Like big stones.
Big stones, yeah, good. It seems like a stone, right? Stone-like structure, a lump. Ribbon. What is that? Ribbon. For example, magnesium ribbon, right? Granules. Powder. Now, so those wordings should be highly noted. Okay, in any other names will to describe the appearance of solid besides lump, ribbon, granules, powder? Any other terms that you have heard it before? Almost, right? Almost there, right? Almost there. So remember, once you see those names, they will tell you indirectly the particle size of it. Okay, so in this case, you may find the particle size will be this order. Okay, particle size will be this order. Okay, you get my point. So which means that if you want to talk about surface area of the solid, so the order will be this, will be quite the opposite. Okay, remember they are opposite. So that's why I always say that this is a trap, right? Especially in MC. Now, how would you think of this concept in practice? So you may see this one and you can get what you mean. Now, what is mean by the larger particle size? We have got a smaller surface area. So of course, that sentence should be put against the extreme, the other extreme, the small particle size. Okay, and we will have larger surface area. So you may find we've got a large block. Now, in case I cut it into 3 pieces, so the surface area for you want to talk about the sizes of it, compared with the block, will become larger. How? So you may find the meeting area, just one below and one above, right? So you may see these two pieces of area where they will have a contact, right, with other chemicals. For example, if it is a metal, if I put it into the exit, you may have a more chance of having an exit to attack here. Now, similarly, the one at the bottom, this the bottom layer above, okay? So altogether, we have got 4 more phases. Can you see that? 4 more square phases, okay? Exposed. Exposed to what? Exposed to another chemical. Now, for example, it depends on where they will be put. If it is put with exit, the exit can also react from here. So you may see that if you want to chop it more from 3 slices to 9 sticks, so the surface area that we may find it more on here, right? So you may find it here. So we have got this all together. For one layer, we have got 4 rectangles, right? While we have got 3, we have got 12 more rectangles. Rectangular faces exposed. Can you get a point? So which means that if I chop the size of the particles to become smaller, the surface area of contact with another chemical should be higher. Do you understand? Because once I chop it, while those surface which is remain intact, right, with the other chemicals originally, they are now be more vulnerable to the attack of the other chemical, because they are now be exposed. Okay, 暴露啊, exposed. They are now be exposed. Can you get a point? Can you get the whole logic about this? Okay, so remember, whenever you see the term particle size, surface area, be aware of these 2 terms. And they will tell it very indirectly by not just directly tell you is surface area or particle size. Is that they will show this type of statement: lump, ribbon, granules, powder. Okay, or maybe fine solid. Now, if you say fine solid, it is usually referred to powder as well. If you say that it is a coarse, you may see the word coarse and fine. Coarse and fine. Now, which means that the particle size is different. You know it? Coarse adjustment, not fine adjustment, not in Form 1 microscope, right? You may see that 2 terms. Any questions so far for that? You understood? You understood the difference between the term? Okay. Any questions? Now we come to again. You are going to consider the reaction between dilute hydrochloric acid and marble calcium carbonate. Of this time, I change it to different surface area. So let's have a recap of fair test. So what is the change of it if I have an independent variable, dependent variable, and also control variable? Can you think of the fair test, the concept of fair test now? Mahim, what is the independent variable on this investigation? Hello, Mahim.
Yes.
What is mean by independent variable? The variable to be
changed.
Yeah.
Or
change.
Yes.
Yes. So what is that?
The mask.
Mass. I changed the mass. Is it?
Is the molarity.
Molarity. Molarity of what? Acid, you mean? Now take a look on the purpose of experiment. The experiment you need to consider is to find out the effect of the solid of different surface area, the calcium carbonate with the surface area, on the rate of reaction between calcium carbonate and HCl. So what's
the independent variable is the different surface area.
Different surface area. Instead, you just mark it as surface area of what?
Of calcium carbonate.
Yeah. Or you just say that it is particle size of calcium carbonate. About the dependent variable, it is the rate of reaction. Okay, rate of reaction between calcium carbonate and HCl. Now, of course, for the measurement method, it depends on many of you. Somebody would love to measure the change in volume of the gas produced, right? But according to our example, you may refer to page 39. This one. So what is the measurement method? So it is measure the difference in mass of the reaction mixture over time. Can you see that? So this is our measurement method. The mass of reaction mixture. So you are going to measure the change in mass. So using electronic balance. Do you understand? So of course, depending on your design, right, you may change the red one to some other method, right? It depends on you. But the whole investigation, the dependent variable is still the same. You are going to investigate the how does the surface area affect the rate of reaction between calcium carbonate and HCl. How about control variable? Control variable, to name a few, Makinya, just name one. In order to make a fair test, what should be kept constant? Makinya.
Concentration of HCl.
Concentration of HCl. Good. What else? Taking hold. Taking hold. Can you think of one more variable? Yep.
Temperature of HCl.
The temperature of the reaction mixture, especially HCl. Yep. What else? Xin chào Hoàng Hiên.
仲有啲乜嘢啊？
Yes.
關唔關個 volume 事㗎 ？HCl
Volume of HCl.
OK，唔該。
Now I still write on the left hand side is because of these two that will affect the flat part. The flat part. So which tells you the number of moles of the product they may refer indirectly to the number of moles of product. Okay, can you get the point? So for the presence, if I change the volume, the total volume of an exit, if I change the mass of solid, okay, you are not altering. You are not altering the rate of a reaction. But of course, it's rather problematic. It's about the mass of solid, because if you say that the mass of solid being small and you're thinking of a bigger one to make it one is heavier, of course, it's not just the mass of solid, but it's also the surface area being different. So it's rather complicated. But if you take a look on the volume of HCl, you may say that even though I add more volume to it, okay, it doesn't affect the rate of reaction. As said last time. Do you still remember last time I tell the case about, right, a boy who want to make girlfriends, okay? If you stay in Changsha, you cannot, even though you have got some girls in Yunlong, Tianshui, but it's too far away from you, okay? So it's none of your business to think of the girls over there. Can you get a point? Because you never have a chance to meet them. So the volume of HCl will not affect the rate of reaction. Instead, they will affect the calculations, the projection of number of moles of product to be formed. Okay, all those they just go back to the equation and check the mole ratio. Okay, and you can get the different answer. Can you get a point? This is what you know it about this part. Any questions? And of course, you may, if in order not to miss every detail, you may think of something like this for HCl molarity, and you may think of because I mark it as HCl, right? You need not think they have been understood that they are of the same basicity. Right, they are of the same strength already. Okay, so no need to tell if you say it is HCl. So the control variable is mainly there. Okay, because these two, the concept of it is already embedded inside because I just mark it HCl. So it's self-understood every time I would use the same type of exit. Okay, if I use the same type of exit, I need not take care of checking whether or not they are of same basicity, nor they are of the same strength. Of course, they must be the same because you are not using the same solid, same exit, isn't it? You understand? Okay, so this is what about the variable table. So you may have got this one. Now, here comes one more term, chips. So where should it be placed in that order? Chips. Where? Chips. Where should it be placed? A testing of English. Chips.
After lumps.
After lumps, yeah. It seems like ribbon, isn't it, right? So
Yeah.
in which is just a thin sheets. So chips can also be put it here. So, but don't worry, I will not be so funny to tell you whether or not ribbon or chips they will have a larger surface area. It's too nonsense to ask so. Okay. Now don't argue. Don't try to ask, right? In case there is a case about ribbon and chips, which one has a larger surface area? No. I will not ask this. But of course I will ask lump and chips. I know which one is particle size larger or which one is smaller. Okay, can you get my point? For chips and granules, for granules we have a larger surface area. Do you understand? Okay, so chips it is something like ribbon. So they would have the 2 points to note about the curve. Please take a look on those two sentences. At the start, the slope of the curve for small bubble chips is steeper than the depth for the larger tips, which means that the initial rate for the reaction with small marble chips is higher, while the small marble chips with greater surface area react faster. This is the first sentence. So how would you analyze this. Analysis is from checking it is tell you the shape of the curve, right? The drop, okay, the dropping trend, and you may find that the small marble chips, they will drop faster than the large marble chips. Okay, can you get my point? So which means this agrees with our sentence to tell you something about the rate of reaction, which is affected by the surface area of solid. While the surface area of solid, it is represented by telling you large or small chips, okay? So you collectively, we will say it as a particle size. Right, that sentence appear again. Can you see that? Can you see the logic, right? The particle size of solid affects the surface area of solid affects the rate of reaction. In this case, the small size, in case the more small size of it, it will have larger surface area, so in which the rate of reaction will become larger, which will tell you why it will have a steeper slope. Of the curve. Do you understand? So I mark it as the blue one, like this. Okay. Now, second case is on the part level off. So you may find it, the curves flatten off at the same mass. That means the same mass of carbon dioxide is being formed. This is because the mass of chips and amount of exit, they are the same. Amount, which means volume of exit, and also molarity of exit. So remember, amount here will have a hidden meaning. It is the number of moles. Can you get a point? So go back to the original statement, okay? Suggested by you. You may see some of you suggest mass of solid and volume of HCl to be considered, right? As a controlled variable. Okay, however, it is not. These two factors will only affect this part, how high or how low it is. Okay, the larger the mass to be added, the exit, the volume of exit is larger volume is added as long as this is the limiting reactant. Okay, as long as it is limiting, so they would more or less affect this one. Okay, in an increase that one, they will make the drop even further. Can you get my point? Of course, if it is in excess, many increasing further increase of the excess limit reactant will not cause a further drop of this. Remember, for this part, we didn't tell you anything about which one is limiting, which one is in excess. So in this case, they will show you these two. Now, but in the reality, while in the DSE, you need to calculate which one is limiting, which one is in excess, so as to tell the number of moles. How does it affect the number of moles? What I mean is this part. So again, it was try to say to a sentence again that you are going to split the curve into two, the one with curves, the one with straight line. Now, which means different things. Curves, you are going to talk about the rate, while for a straight line, you talk about number of moles. If you want to talk about rate, you are going to think of what are the factors are affecting the rate of reaction. While if you want to talk about mole of product form, you are going to think of the number of moles of limiting reactant, and this will affect the number of moles of product form. Do you still remember that one? Now I just say it once again. Any questions so far? Now remember, please be aware of these two parts. Now, otherwise you cannot solve the problem 37.2. You may find that one very, very difficult. Questions? How about this? Now we have got two cases to be put, right? Try to base on this as a start and tell me what should be curve be like. When ethanoic acid reacts with marble, ethanoic acid, what is the formula of ethanoic acid? CH3COOH. Now, our important hint. React with marble, which is marble, is calcium carbonate. The progress of reaction can be followed by monitoring the number of moles of CO2 released with time. So this is the dependent variable. Okay, the weight measurement method. You're going to measure the mass at one of most of it. Of course, it is related to volume in particular, right? While in practice, it's quite hard to just directly tell number of moles in y-axis. Actually, it must be volume of CO2 and do the mathematical treatment later on. Don't worry about volume and number of moles. Are they the same? They are not the same, but how come they will have the same shape? How come they are of the same shape? Volume of CO2 and number of moles CO2, what is the relationship between the two? Do you realize every time I keep on asking this, right? Gentlemen, what are the relationship between the volume of CO2 and number of moles of CO2?
They are directly proportional.
Yeah, they are in direct proportion, right? So remember, okay, I always ask you this type of questions. Otherwise, you may find difficult to comprehend, which means that if you are going to draw the same very similar graph, volume of CO2 versus time, it will give you the curve very similar to this. Okay, you get my point. So we call it direct proportion. But of course, the exact number is different between the two. Because the quantity is different. Okay, the unit is different. Now, the curve shows how the number of moles CO2 released various time with they have got 2.00 gram marble, small marble chips. Plus 30.0 cm cube, 0.600 molar ethanoic acid. Now remember, this one is in excess, while this one it is limiting. They will show you this graph. You understand the situation, right? So how about A? You are going to give another sketch, another case, right? So I change it to 2.0 gram large marble chips, 3.00 cm cube, 0.600 molar of ethanoic acid. What would the graph be like? What would the graph be like? Now, in order to answer that questions, you are going to tell in two aspects. You're going to tell it in two aspects. One, how does it bring to the effect on the rate of reaction, which means the curve part. Second, is about the one level of the flattened one, the flattened part. How does it affect the number of moles of CO2 to be formed? Do you understand? Now remember, we have got that two perspectives to consider. Oh, Him, what do you think? Two aspects, rate and mole.
Yes.
Yes, answer please. Yeah. So just tell me yes, right? Again, two ways to answer, right? You are going to have this. First of all, how does this affect the rate of reaction? With this policy, right? You change. What is the difference between them? 2 grams of small bubble chips, 30.0 cm cube, 0.60 molar, this, right? Because you have got so many information here, so much information. You are going to opt one out. Tell me what is the difference in the data. What is the difference in the data?
Number of mole.
Number of moles, they are different. How different? 2.00 gram is equal to 2.0 gram. This is equal. This is equal. Can you see the number? They are the same.
Yes.
So if that is the case, you are now referring to number of moles of the CO2 to be formed. It is larger, smaller, or the same? Would it be larger, smaller, or be the same as the first case?
Small marbles large.
Sorry?
Small marbles large.
Small marble chips. But what do you want to tell? I cannot hear so clearly. Could you please speak louder? Again, two part, number one and number two. What do you want to tell about number one and number two? You want to tell number one first, or you want to tell me number two first? What is the change in number one and number two? The area in number one and number two?
Number one changed by the surface area of the
Yeah.
small marble chips. And number
Yes.
two is the number of mole.
Yes, tell me the change. So number one, it just tell you surface area.
The surface area larger and the reaction rate faster.
Yeah, in this case, what will the shape be like if I show it as X, the curve X? What will it be like? A steeper curve or the less steep curve? Is it steeper or less steep or the same?
The new one is steeper.
New one is steeper. Agree? How about the others? Agree?
No.
No. So what would it be like? Steeper, less steep, or the same, or remain the same?
Less deep. Less deep.
Less steep. Why? The answer is less steep. Why?
Because it got larger surface area, therefore the rate of reaction is smaller.
Larger surface area. Which one has a larger surface area?
The repeated experiment, the second
The X
experiment.
one. The case for X, large marble chips, which means larger surface area. You mean so?
No, smaller
marble
surface,
chip.
small surface area.
Okay, small chips like this. Okay. So which one has a larger surface area?
The first one.
The first one. But for second case, the explanation is the opposite. The large marble chips have a smaller surface area. Except before in our very first lesson, I just said that it's a trap, right? Oh, here, take a look on this. Particle size of solid decrease, the surface area increase. You are going to tell it in opposite. The particle size of the solid this time is become larger, which means that surface area of a solid becomes smaller. Just like what? You just like have a small marble chip, just like powder, while large marble chips, it seems like a lump of a solid. Okay, you may think it like this way. Okay, so this one should have a more surface area. the small marble chips with a larger surface area. So this is smaller surface area, which means that the rate of reaction will become smaller. So you are going to put a graph like this, okay? When would you come to an end? Now, for the first case, it is written as this on here, right? Would the ending time for the blue curve longer, shorter, or will be the same as the first case? The second thing I would like to draw attention to it, I repeat, would the ending time of the reaction, the completion time, the same, or different? If it's different, would it be shorter? Will it take shorter time or longer time? 麥建陽
It is ended after the line.
After which line?
The middle line.
Middle line? Where is the middle line?
即係中間嗰條藍色線。
So what will it be like? Now I would like to draw it like this way. Like this. So what will happen next?
繼續上去咯。
Until
Until 同嗰個紅色線重合。
and then?
跟住就直線嘅喎。慢
Same
慢變
or high level, lower level?
same level.
Same level, not same. Same level.
Okay.
Same level. So my question is, what is the completion time of reaction? The completion time is longer. You simply tell me like this and the problem has been solved.
Okay.
It takes a longer time to complete, which means that the flat part would appear later. Okay? Longer completion time. Okay, you get my point? So it is X. Okay, please remember to label it as X like this. So we are going to take a look on two ways. One, the rate of a reaction will be affected by the surface area of solid. So this time the surface area of solid drops. So which means that the rate will become slower. Okay, so which means that the whole progress is slower. So slower, which means initial rate slower until the end. The end time, we call that the completion time, will be also lengthened. Okay, will become longer. Number one. Number two, if you want to talk about number of moles of carbon dioxide to be formed, please check what you are going to check the physical quantities here, right? This part, you're going to check 2 gram the same, 30 cm equivalent the same, 0.6 molar the same. The acid used is the same, right? So of course, all those matter. If you want to talk about number of moles, they're the same. Of course, carbon dioxide formed to be will be produced with the same amount. Do you understand? So this is a way to understand how to draw the graph correctly. How about the second case? The second case, I would like to show it in green line. The experiment was repeated using 2.00 gram of small marble chips and 20.0 cm 0.800 molar hydrochloric acid. So what would be the curve be like? Again, I split the graph into two parts. One is with a curve, the other one with what? With a flat part. How would it be like? Anyone who can answer that separately? Now remember, the way to solve the problem is to make the big problem become smaller and solve it one by one first. what would it be like? 鄧浩源。So you may tell either part, the curved part or the flattened part, what you want to tell. Hello. Hello. So what to compare? What you want to compare with the red curve or the blue curve, right? Against Y.
The red curve.
Yep. Use the red curve for comparison. Yeah. So what is the difference between the two?
The concentration of the acid.
Yes. Only this?
And the acid used.
Acid use is different, huh? Ethanol acid versus HCl. What else? What else is different? The volume is different, right? But if you want to talk about volume, it doesn't tell anything about the rate, okay? So it is something about mole. But for these two factors, they will affect our rate. But of course, if you want to talk about mole, we need to consider the molarity as well. Do you understand? Okay. While for this, for the second case, you are talking about surface area with affect the rate. Large, right? Can you see the word? So take a look. What is the effect? The first one, what would the graph be like? Steeper than red one, less steep, or the same? Zhao Zheng.
It should be steeper than the red one.
Yep. Why?
Because the strength of the acid is stronger. It's a strong acid, and then the concentration of the acid is higher.
Okay. So we have got two effects to be considered. First of all, it is molarity. Molarity of acid is being higher, and also the strength of acid being higher. So what is the combined effect? It will cause you a combined effect, which will cause one iron's concentration higher. What is that iron? What is the iron? Zhao Zheng. Now we call your memory by writing the ionic equation. So both will affect the one ion concentration, right? What is that?
The ionic equation.
Yep, ionic equation, yes.
Calcium carbonate and hydrogen ion.
Hydrogen ions, two hydrogen ions. So that is the answer. You are going to have the change in concentration of hydrogen ion. So remember, this will affect hydrogen ion concentration. This one will affect hydrogen ion concentration. Both, they will cause it increase, right? So of course, because of that, okay, for the reaction between calcium carbonate and acid, you know, it's mainly the reaction between calcium carbonate and hydrogen ion. So the concentration of hydrogen ion plays a very important role. to affect the rate of reaction. So of course, the first one will become, the curve will become steeper at the very beginning. Okay, steeper. So which means that if it's steeper, they would have a earlier time of completion, isn't it? Earlier time. So this is the timing where there is a reaction complete. So you may find somewhere it is complete, right? Which is before the blue vertical line. Okay, for example, the ending time, you may define it somewhere here, for example. Now it depends on you, right? As long as it ends much earlier, it is okay. But the question comes, would I end it here, upper or even higher? Now you are going to calculate the number of moles. So don't get too worried out to draw the middle part. Please draw the end part first and then match the two. Do you know why? Because I still don't know which one is limiting, which one is in excess in the new case. Mr. Chin, don't tell me that I need to do the calculations. You have to. Please calculate the number of moles of what? Hydrochloric acid. Hydrochloric acid, which is what? Could you please do it, the calculations now? Number of moles of hydrochloric acid. It is multiplied as molarity times volume. So what is the answer?
0.016.
Yeah, 0.0160 mole. So the calculation should be like this. So you may get it 0.0160 mole. How about marble chips 2.0? So how is 2 the mass over molar mass? Do you still remember that? How you get the answer? It is 2.00 grams over 100.1 gram per mole. So what is the answer for that? Now, Matthew, tell me what is that? 2.00 over 100.1. 0.1. It's about 1 over 50.
0.0200.
0.02. Is it?
Yeah.
0.
Yeah. 0.0200.
Okay, so take a look on this against the equation 1 to 2 mole ratio. So according to this, which one is limited? Which one is in excess? Calcium carbonate in excess or HCl is in excess? Matthew.
Calcium carbonate is in excess.
Still in excess. So which means that the number of moles of HCl will limit the formation of CO2. Can you get my point? So that's why we need to go back to this. You are going to calculate one more thing, the number of moles of ethanoic acid. So what is that? M times V, it is 0.600 molar times 30.0 times 10 to the power minus 3 dm cube, which is equal to 0.0180 mole. Can you get the point? So it is still limiting. Now, according to the question, you say that it's in excess, right? Even though I do the same calculations, you may find that this one the same, and the excess should be in 2 mole. So you need not consume all 0.0200 mole of calcium carbonate. So it is in excess. Okay, you get a point. But the case is that exit, the number of moles of exit will limit the carbon dioxide amount to be released, right? So, can you get a point? So how what does it affect the number of moles of carbon dioxide to be formed? Is it the same, larger, or smaller? In this case, for the case of Y, Lam Hiu Feng, is it the same, larger, or smaller than the red one, the red curve?
Larger than the red one.
Larger than the red one. Why? HCl. Take a look, HCl. The number of moles of it is 0.0160. For ethane exit, the number of moles is 0.0180.
Smaller than the red one.
Smaller, it's smaller, okay? Just count the number of boxes here, right? So we have got big boxes. Try to count the big boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, what a coincidence, right? So you please see that. What a coincidence. So we have got 9 big boxes to form 0.0180 mole, right? Of exit to form that CO2, which, well, HCl, it is 0.0160 mole. So each box is just 0.002. So which means that 1 box lower. Okay, you get a point. Remember, it will end it earlier. So how is the curve be like? First of all, you draw a line here, earlier time to finish, right? For example, here, this is the part, you find it is earlier time of completion, right? You just stop it here. And then you may find the 2 parts, right? So what you're going to do is to bridge the 2. And try to make the curve as smooth as possible. Now you find it's not smooth. Okay, that's why I always ask you guys to use HB pencil to draw a curve, right? Not like this. So by doing so, here comes Y, a mark it Y here. This is the graph. Do you understand? Now, I do hope by doing so, you can get to know more how to do the graphical way. Easy, difficult, or what? Now, you may find some more things to consider, right? While you draw this graph. Do you realize you need to, oh, sorry. Have I, yeah. Not appearing. I press it wrongly. So you have got so much to consider, right? First of all, you are going to find out the difference in the factors. Okay, it can be concentration or it can be surface area. Now, all of you, please mark it down your level of understanding at the same time. Now, shall we have a conclusion now? So second is on the completion time, okay? So it is much related. If you have got the reaction faster, of course, it will take faster time to complete. If the reaction is slower, they will have a longer time to complete. Second is the term, the number of moles, what it means, the flat curve. So whether the level is upper or lower or will be the same, you need to go back to the number of moles of the reactant. While you do that, remember to check which one is limiting reactant or which one is in excess. Okay, this example will serve a very great example in order to let you know the two factors coming together, and you may have that curve, right? Can you find it more complicated than before? So as said before, so we have got two parts of the curve, right? The one before, you talk about the rate, and also please consider the time of ending. Now, for example, I didn't tell you anything about ending, right? Can you see that? The smaller surface area, the one, they will have a longer time to complete. Can you see that? The ending time, it is longer. Can you see that? So that's why you will tell it like this way. So go back to your fair test, the concept of fair test. Once you read it once again, do you find that for the left-hand side, those items you will not say it again, right? Do you agree? Okay. So much for today. I will see you guys next week. Bye bye. Bye guys.
Bye.
拜拜拜拜。
係，
拜拜
拜
Mr. Chin，
拜。
拜拜拜拜。
先生，
係咩事？
我有啲嘢想問，即係你嗰個 event on the exit 咧係一個 exit，但係計到佢 number of mole of hydrogen 嘅咩？但係佢唔係應該係一個即係partially ionized 嘅一個 exit 噶嘛？咁出咗嚟，咁可能其實嗰個number of mole of hydrogen ion 其實係可能細過hydrochloric acid 嘅喎，唔係咩？
Good question. Now, if you want to talk about the hydrogen ion concentration, of course, it's lower. Now, you understood, right? You understand that part, right? But for the ending of the reaction, if you want to talk completion of reaction, we still have that equilibrium, which means that whenever you have got a consumption of hydrogen ions in the solution, the whole equilibrium equation will still continue to go it to the right hand side until all acid will be reacted. So that equilibrium side, they will have a fixed ratio of the concentration of hydrogen ion, the salt ion, as well as the acid itself. We have got a constant ratio. So you may know it as equilibrium constant, a very complicated term. So it is calculated as the concentration of it, and also the concentration of acid. So which means that during the whole progress of reaction, that arrow will continue to go to the right hand side until all the chemical will be consumed. So what is meant by that? Once I talk about the final calculations of the number of moles of CO2, irrespective of the strength of the acid, just calculate M times V and you can still get the answer. Can you get a point? Just take a look on the answer because all those chemicals will be finally be consumed because we have got that double arrow, right? They are still there. They are still there. So whenever the hydrogen ion, they will drop in their concentration, the whole arrow, they will be shifted to the right hand side in order to accomplish, to replenish the loss of it until the end, until we don't have any unionized form of acid. Do you understand? Okay. Oh, it's time to go to the third lesson. Okay.
Okay. Bye.
Please. Bye bye. Bye bye. Bye guys. Bye guys.
Bye.
Bye.